Hello, Geometry. This is the last section. Be a whole chat. I'm kind of excited, and I can work on chapter 6 right before Thanksgiving. It'll all be good. Okay, so inequalities in two triangles and indirect proof. So our learning targets, I can use inequalities to make comparisons in two triangles. There's something that we're going to talk about called the hinge theorem, so I can use it in the real world. I've seen lots of pictures with alligators about this. In any case, first of all, write the if-then form, converse, inverse, and contrapositive. Remember all of that? But this is going to be an actual equation. So let's see here. What do we got here going? Let's see. All right. Any case, if 3x minus 8 is equal to 22, then x equals 10. So far, so good. Okay, so this is the if-then form. And then we're going to do the converse. Remember what the converse does? Switch it around. Okay, so if x is equal to 10, then 3x minus 8 is equal to 22. Okay, so now we have inverse. If 3x minus 8 does not equal to 22, then x does not equal 10. And contrapositive, maybe we switch it around and it has a negation. If x does not equal 10, then 3x minus 8 does not equal 22. All right, so that probably brings back some scary memories. Good thing I have that on the back board, right? Okay, here we go. Number 2, in triangle ABC, let's see here, let's draw a triangle ABC. Okay, BC is 18. AB is 13, and AC is 16. List the angles from least to greatest. Okay, so the size of the angle. Well, this is the smallest side, so the smallest angle has to be angle C. Okay, this is the middle side, so the angle opposite, angle B. And the largest side is 18, so the angle opposite is angle A. All right, so that kind of corresponds to this problem. I showed you last video with a set of scissors. Notice the distance between the scissors of the opposite distance from like here to here. I have a small little angle here, and of course this segment is congruent to that one. Well, what happens if I take the scissors, it's kind of hard to see, I'm not sure why the color changed, they still have the same length, and I make this angle a little bigger. What's going to happen to the size opposite? Okay, it's a lot longer. Okay, so I have a bigger angle here. Bigger angle, longer side opposite. You probably were able to deduct all of that from last video. This is actually called the hinge theorem. I had a different picture in my former notes. It was awful. It was really blurry. You couldn't see it. So I thought, this is a little better, except for it takes a lot more space. Here we go. Hinge theorem. When you close a door, the angle between the door and the frame gets smaller. Angle small. Actually, they're showing it to you up here. Then when you open it. So the hinge theorem says, if two sides of a triangle are congruent, okay, so like these two sides, and the included angle, the angle in between, are not congruent, the longer third side is opposite of the larger angle. Okay, so angle A is a lot bigger, so BC is going to be longer. All right, so this is kind of hard to see, so I'm going to write it out. Measure of angle A is greater than the measure of angle X. Then BC is greater than YZ. Okay? Hopefully that makes sense. Bigger angle, bigger side opposite. Small angle, smaller side opposite. All right. Moving on. Ooh, the converse. So before I had this on one little picture, so it took up a lot of space here. If two sides of one triangle are congruent to the other two sides, and the third sides are not congruent, then the larger included angle is opposite of the longer side. Okay, so now they're saying if this side is longer, then that angle's bigger. So it's hard to see, then measure of angle A is greater than the measure of angle X. Okay, so we're talking about the angle that's in between the congruent sides, corresponding congruent sides. Well, look at this picture. It's kind of weird. All right, so given that BC is congruent to DA, okay, so BC and DA are congruent, how does angle ADB, that's angle 1, compare to angle CBD, that's angle 2? Okay, let me split these apart. It's kind of hard to see. Okay, would you agree that they both have this side in common? Okay, so look at this. I'm now comparing angle 1, the included side between the two side lengths that are congruent, and angle 2 between the two side lengths that are congruent. Notice opposite of angle 2, the length is 34. Opposite angle 1, the length is 36. Well, what does that tell us? Angle 1 is greater than angle 2. Okay, so be really careful. So when you're working with inequalities, you might want to definitely make sure that you put an arc through the angle. I like to do that, and I know I've been slacking in that department because it takes up more time, but I think we can handle that. All right, here we go. A little number story here. Two runners start together and run in opposite directions. One goes 1.5 miles, changes direction, then goes 2.4 miles. The first runner starts due north and turns 100 degrees. Okay, so let's say they're going to start right here. The first runner is going to go due north 1.5 miles. And then it, or he or she, let's see, turns 100 degrees. Okay, so let's say they're going to turn 100 degrees. 90 would be straight across, 100 would be like this. Okay, so here's 100 degrees. And then they went 2.4 miles. Obviously, this is not to scale. Let's see here. Two runners start to go. The first runner goes due north and turns 100 degrees towards the east. The other runner starts, okay, so that's one runner. The other runner starts due south and turns 130 degrees. Okay, so this would be 130. And they're going to go 2.4 miles also. Okay. Both runners return to their starting point. This was also 1.5. Okay, so they both went 1.5, then 2.4. Okay. Which runner ran farther? Okay, so here we go. This runner went 100 degrees. Well, we have a straight line here. So if this is 100, this is 80, because remember they're a linear pair, supplementary. This is 130 degrees, so that means this is 50. Well, look at this. I have congruent sides, and look at the included angle. This angle is smaller than that one, so that means this is my longer side. I'm going to say big, small. All right, so what do we say, the first runner? Runner 1, because last leg of their run was longer. All right, now we actually haven't figured out what the length of that is. There's something called law of sines that can find this for you. I don't know if did we do law of sines? I can't remember, but law of sines will find the actual distance these are. But let's not worry about that right now. Okay, we're just applying it. I've seen this exact same problem with tanks and horses. All right, indirect proof. Okay, so indirect proof procedure. Assume that negation of the desired conclusion is correct. Write a chain of reasons until you reach an impossibility. This will be a contradiction of either your given information, a theorem definition, or another known fact. They do this a lot in AP Statistics. So if you take that your junior or senior year, that'll be great. And then they state the remaining possibility as desired conclusion. All right, so observe example 3 in your book on page 339. Okay, so example 3 says, given x is an odd number, and x is not divisible by 4. So write an indirect proof to show that the sum of two odd numbers is even. Oh, okay, so example 3 in the book was an odd number and it's not divisible. So this is going to be actually similar. Okay, given a and b are odd numbers, prove that a and b is not, or is an even number. Okay, so step 1. Assume a plus b is not even. Okay, so we're negating it, all right? Step 2, actually, let's see here. If we assume it's not even, which is the same as saying it's odd. As, a plus b is odd. Okay, step 2. If a plus b is odd, then, watch this, a is equal to 2m plus 1 and b is equal to 2n plus 1. I picked two different values. Okay, so a way to determine if something is an odd number, make it even. You can always make something even by doubling it, multiplying it by 2. Because every time you multiply something by 2, you make it even. But if you add or subtract a number, it's going to guarantee an odd value. So we have this. Then a plus b equals, okay, I'm not going to use massive substitution here, 2m plus 1 plus 2n plus 1. And let's kind of clean that up a little bit. 2, I'm going to factor out a 2 here. Okay, m plus n plus 2. Okay, combine these two, and I factored a 2 out of there, which is equal to an even number. How do I know this is even? You're doubling it, and you're adding 2, so it's going to stay even. This contradicts the assumption. Okay, remember, so a plus b cannot equal an even number. Well, we just did it. A plus b is equal to an even number. So a plus b is not an odd number. Okay, this is our contradiction. Step 3. So a plus b equals odd is false. Therefore, okay, three dots forming a triangle means therefore a plus b is even. Interesting, huh? There you go, indirect proof. All right. Write an indirect proof. Okay, we're just going to not doing a 2-column proof, but oh, I spelled indirect wrong. Okay. I find this interesting because when I had these notes originally with those with the 3 boys prior, and they would enjoy finding all of my typos, and then I circled them and corrected them. But apparently I'm finding some that they didn't. Okay, so write an indirect proof for the corollary of the triangle sum theorem on page 220 that acute angles of a right triangle are complementary. Okay, so we're going to given, I'm going to label these 1, 2, and 3. Okay, so we have to have a right triangle. Angle B is right triangle, and these have to equal 90. Okay, so let's first assume that the measure of angle 1 plus the measure of angle 2 does not equal 90. Remember, we have to negate it. So case 1. 2 cases here. Interesting, right? If the measure of angle 1 plus the measure of angle 2 is less than 90. Okay, we're going to do less than 90 and greater than 90. Then measure of angle 3 has to be greater than 90. Okay, remember your triangle sum theorem? They have to equal 90. So if these two are less than 90, then it has to be greater. But that contradicts. That angle B is a right angle. Okay, how about case 2? Take a wild guess what that's going to be. Case 2 is going to be greater than 90. Make it like a, obtuse or whatever. So if the measure of angle 1 plus the measure of angle 2 is greater than 90, then measure of angle 3 has to be less than 90 degrees, okay, because of the triangle sum theorem. Again, this contradicts that the measure of angle 3 is equal to 90 degrees. So you start with a negation of what you believe is true and work towards it. I think it's kind of cool. All right. Objective: to use deductive and inductive reasoning in direct and indirect proofs. Okay, so logical reasoning. Deductive reasoning is the process of demonstrating the validity of a certain statements can imply the validity of statements that follow. All prime numbers greater than 2 are odd. 37 is a prime number, therefore 37 is odd. Or inductive reasoning. The process of making generalizations based on observed data, patterns, and past performance. You have never seen a pelican in the desert. Therefore, pelicans probably don't live in the desert. Okay, so kind of distinguish these two. Well, sum it up. Here is our homework. I was getting not very creative there. And our Common Core standards. So hopefully you had a really nice weekend. It's a little chilly out there. Next Tuesday is going to be really cold, so hang in there. Take care.